A system of equations is a set of two or more equations that work together to describe a situation. The solution to a system of equations is the ordered pair or pairs that solve both equations. In other words, a point is a solution to a system if that point is on both of the lines in the system. So it's possible to have a solution, to have infinitely many solutions, or to have no solution at all. So let's look at those basic situations. So we will have a solution, so just one, to a system if we have two lines that simply intersect with each other. So let's say I have a line that comes this way. Maybe it's got a slope of 1/3 and a y-intercept of 2. And then I have another line that also goes through this point, -3, 1. Maybe it has a slope of -1/2. Oops. So drawing these two lines, I can see that this point, -3, 1, is on the line with the positive slope, and it's also on the line with the negative slope. So this system has just one solution, and the solution that it has is the point -3, 1. It's the one point that they both have in common. But that's not the only thing that can happen when I have two lines drawn on the xy plane. I could have no solution. So we have to think about that for a minute. These two lines have a solution because they run into each other. So I would have to have lines that don't run into each other at all in order to have no solution to a system. So let's say I start by drawing that same line that I had before with that slope of 1/3 and a y-intercept of 2. If I want to draw another line that doesn't run into this one, it would have to be parallel. So for example, if it had a y-intercept of -1 and went up 3/1, those two lines will never meet. If there isn't any point that's in common between the two lines, then there's no solution. So for this one, I have to have parallel lines. I would need to label 4 points on the graph because they don't share any points in common, and we know that we have to have 2 points labeled on every line. Now, the next situation is actually a little bit hard to just draw, but it's the situation of having infinitely many solutions. I'm going to come back to this one after we've looked at a couple of examples below. So let's go down and we're going to solve three systems by graphing. So if I have the line y equals -3x, we know that that has a y-intercept of 0, 0 and a slope of -3. So I'm going to start at the origin and I'm going to go down 3 and over 1 and also up 3 and back 1. And I'm going to draw my line. I'm not going to label yet because I want to wait and see where this other line goes. Now, this other line is pretty simple, but it's written in a strange way that sometimes throws students off. It actually helps if we reverse the order. So we pick up that -x, we let it be first. We pick up that +2, we let it be second. Now it's a little easier to see that the y-intercept is the point 0, 2, and the slope is -1. So I'll go to the y-intercept of 0, 2, and I'll go down 1, right 1, and also up 1, left 1. Once I've drawn these two lines, I can see that they meet in this one point. They meet at -1, 3. I'm also going to label one more point on each line for a total of 3 points on my graph. And then off the graph, I'm going to identify the point -1, 3 as the solution because that's the point where these two lines meet. Let's take a look at the second system. The first one's pretty easy to graph. We can see that the slope is 2 and that the y-intercept is the point 0, -1. But this one's written in standard form, and I can see that 2 isn't going to go into 3, so I've got to do the solve for y method. So I'm going to subtract 2x. I've got -y equals -2x plus 3, and then I'm going to multiply both sides by a -1. So I have y equals 2x minus 3. So I can see that I have a slope of 2 and a y-intercept of -3. Now, right away, I'm noticing these two lines have the same slope. And we know that lines that have the same slope are parallel. I can also see that they start at two different points. So they're not the same line, but two different lines. So I know these two lines are going to be parallel and they're never going to meet, which tells me that there's going to be no solution to the system. Even though I know that already, I am going to draw and label the two lines. But then when I go to state the solution, I'm stating that there isn't a solution. So I'm starting by labeling my y-intercepts, and then I'm just picking one other point on each line to label. It doesn't matter what point that is, just anything convenient, but I do need to specifically state that the system has no solution. All right, we have one more system over here that we're asked to graph. Nice straightforward equations, y equals 3 and x equals -4. So we know that y equals 3 is all the points that end in 3. So no matter what they begin with, they end with a 3. So that means I'm up 3 everywhere. We can see that that's going to be a horizontal line. And then the second one is all the points that begin with a -4. So that's going to be a vertical line using all the points that start with -4. Now you'll notice that they intersect at the point -4, 3, -4, 3. So the solution is the point -4, 3, but I do still need to label a couple of more points because I need one on each line. All right, let's go back and talk about that last situation. And I'm going to base my work off of this second example that we did here, where we had y equals 2x minus 1, and then y equals 2x minus 3. Let's say I have a system that's almost the same as that second system. Notice I picked the same y equals line, and I took 2x minus y equals 3, and I just changed it to be 2x minus y equals 1. So we already know that y equals 2x minus 1 is going to start at -1 and go up 2 and right 1. So let's go ahead and sketch that line. And then we would look at this one and say, okay, if I have 2x minus y equals 1, I would subtract 2x and then multiply both sides by -1. And when I do that, I realize that this equation describes exactly the same line as the first equation. So I have a system of two equations, but they're really the same equation, the same line. So I can't graph something else because I've already graphed this line. That means that every single point that was on the line I already graphed is also a point on this second line that I'm supposed to graph, but it already exists. That's what happens when we have infinitely many solutions. So we might want to make ourselves a note here. We have infinitely many solutions if we have the same slope and the same y-intercept, because that means we really have the same line. We have no solution if we have the same slope but different y-intercepts, because then we have two lines that will never meet, so they have no points in common.